What's up, Cal Gang? Welcome back to some dynamics. So let's solve this problem. So what do we have? We have two spheres, each of them are 3 kilograms, and then we have this moment that's being applied counterclockwise equal to 18 Newton meters. So it's going to make this whole system spin, right? And it's laying flat. So the time required to reach 3 meters a second from rest, that's what we're solving for. So it's going to spin, it's going to start accelerating, and it's going to eventually reach 3 meters a second. Let's find how long it takes. So we're going to be using our angular momentum equation. So angular momentum says that our initial angular momentum plus the sum of the moments integrated over time is going to be our final momentum. Right? So conservation of momentum, but we're going to be putting energy into the system through this moment. So let's go ahead and use this equation. So first of all, this system is starting at rest, so we're going to have no angular momentum initial, so that's going to be equal to 0. So then what's this integral going to be? Well, there's just going to be one moment being applied. There's no forces or anything. So we can make it the integral of our moments, which is 8t. So it's going to be 8t dt. Right? And for our balance, right, we're supposed to integrate from when we start to when we stop. Now we don't know when we stop. That's what we're solving for. So let's say we start at 0, our time starts at 0, and then we're going to set it to time, right? This is the time that it takes to reach 3 meters a second. So this is the variable that we're solving for, t. So let's set it to our final angular velocity. So of course there's 2, so we can do, right, the angular momentum, angular momentum is going to be mass times radius times velocity. And this is velocity 2. So we need to consider that this is the mass of our whole system. This is the mass of this and this combined. So it's going to be basically 2 mass. Right, so let's solve this integral. So of course this is going to become 4t squared. Now if you do the balance, that t is going to come down and that 0 is going to cancel out. So we're going to just get 4t squared is equal to 2 mass radius velocity 2. So we're solving for t, so let's go ahead and rewrite this equation. Oh, I'm looking at the wrong note. That explains why I was so confused. Okay, so then, right, so this is going to become t is equal to mass radius velocity 2 divided by 2 square root of all of that. So let's plug in the numbers, right? So it's going to be square root. The mass is 3 kilograms. The radius, what is the radius? It's 0.4 meters. Velocity 2 is 3 meters a second, right? That's what we wanted to reach. And then this 2 on the bottom. So you solve this, you get the time is equal to 1.34 seconds. And there we go, we solved the problem. So yeah, not too tricky, just about making sure you know how to use this equation, basically understanding it. So if you don't understand yet, that's all right. Feel free to check out my channel. I got a whole playlist on problems like this. Thanks for your support, and I'll see you in the next video. Peace.